this is part 1 of lab 3 and this Charlieplex LED. This will be the schematics. I'm going to refer this as resistor 1, resistor 2 and resistor 3. These are the ports we're using for each resistor that comes out from MK20, and these are the actual implementation of the circuit. This is resistor 1, resistor 2 and resistor 3, and it's implemented the switch which runs into the MK20. So these are the codes for our Charlieplex LED. So this LED here is LED 1, this LED here is LED 2, the outer LED is LED 3, inner LED is LED 4, the outer LED is LED 5, this one, and the inner LED is LED 6. So now the switch is in 0. See, the switch is now in 0. So I'm going to turn it into 1. So it works from this way, 1. So it works from 1, 2 and 4. Right? So I'm going to turn on this one. As you can see, when I turn on 1, D1 lights up, because when D1 lights up when it's 1, so it follows the thing. If D2, if 2, D2 lights up. If the value is 3 here, then D3 lights up, and so on. So I'm going to show you the 6 LEDs which lights up according to their own value. Okay, now the switch is inputting value 2 and D2 is lighting up. Next we'll go to D3. This is D3. As you can see, the outer LED D3 is lighting up. Not sure if you okay. See, the outer one is lighting up, the inner one is not lighting up. That's D3, the inner one is D4. Now we are going for D4. This is D4. The inner LED is now lighting up, which is D4. Next, D5. This is D5. As you can see, 1 and 4. D5, the outer LED is lighting up, which is D5. And the innermost LED, the last LED, would be D6. I'm going to show you D6. So this is our final circuit, D6. As you can see, the inputs are 4 and 2, and the outermost LED D6 is lighting up. So this is our Charlieplex circuit with implementation of switch. I've showed you switch, each scenarios of switch where it lights up from D1 to D6. Thank you. Of analog to digital converter. So this is a circuit by MK20. We're using ADC channel 14 that goes into resistor 270 ohm. This resistor we use SIP, then which connects to a potentiometer. Alright, so we have to print the final result, the ADC channel number XX equals 2 with the decimal. Since the system doesn't support floating point, we have to do our own calculation to print out the final result as this. So this is the code. So we include derivative clock, everything. Then we use ADC channel 14, and this is function for delay, function for ADC initialization and ADC conversion. This is the function for calculating voltage. We'll go to the functions first. First functions is the delay function. This is a delay function, a simple delay function to pass time, and this would be the conversion where we've set up the channel as ADC channel 14, and while this while loop waits for the conversion to finish, then stores the data into an variable. This is the raw data of the ADC. So this would be the ADC initialization where we've configured the setting to be normal power with clock division 1 and short sample time, and we're also using mode 2 10-bit mode and a bus clock. And the second configuration, we disable asynchronous clock and normal conversion sequence, default sample time, and so on. So each of the setting we've done, and these are the descriptions of the settings. So this while loop waits for the conversion, the cocoa mask, for the conversion to complete. If the conversion is complete, then it displays flag, a good flag, then if the conversion is not successful, if the calibration failed, then it prints out calibration failed. This is the calibration flag, which indicates whether the conversion failed or became successful. These are the code to calculate voltage. We've declared few variables for the first digit. Since our results should be like this, we've allocated few variables for each place. So here you see, since the calculation of turning the raw data into the float point and printing out in the kitty. And these are the code. We initialize the clock, then we initialize the clock for the ADC mask, then we initialize clock for port C, then here we have enabled marks in port C0 and set C0 as an input. So at the start of the program, this initialization prints in kitty the delay, then initializes ADC, then after that it does the conversion and calculates the voltage, and finally prints out in the kitty. So I'm gonna show you the program running. So this is the kitty, and when you start the program, it does the conversion. Now you see, this is our circuit. This is the potentiometer connected to SIP, which is a 270 ohm resistor. Connection are simple. This black wire here is connected to VCC, while this yellow wire is connected to ground, and I've extended ground from here to here. So the SIP also is connected to the ground, and this is connected to the first resistor in SIP, and this is connected to the ADC14. So when you see, so now when I use this potentiometer, the value outputted, the voltage value also changes. So see, the value printed is 0.30. As I increase, the value of the voltage slowly increases. So the raw data is converted into voltage, and at maximum it's 3.30 volt. Thank you. Modified part 2, where I use part 2 of the initial one to measure the light level available from light sensor from FDRM using channel 19. So this is my code. All the codes are same. Just in the main code, instead of all the conversion, you just put a variable light level to conversion, then you print out the light level into the kitty. So this one we use mod 3, 16-bit, and everything else is same. This checking for calibration whether it's complete or not, and printing the message whether the calibration is successful or failed. This is the same as previously, and this simple loop. You can see here we've used channel 19 for this, where the light sensor is. So as you can see, when I started the code, it initialized. Then I'm gonna control the sensor values, these light values with an torchlight. So now I'm gonna use this torchlight to control the value of the light sensor. So you see, when I focus the light here, the value changes. Then when I take the light away, the value increases. That's all. Thank you.
Hello, today we are doing the lab 3 part 3, which is this application integration, and you can see this is the code we are using, and these are the initial peripheral declaration, which are derivative and clock and standard input output, and these are the outputs we are defining to port A, port B, port C, which are pin 12, 4 and 5, which is over here in the here we can see port this pin 12 and pin 4 and pin 5. And then you can see these are the delay, this is the delay function, and this is the initialization of the ADC function, and this is the function for the ADC conversion, and this is the function for the initialization of multiplexing, and this is the setting the LED values for the, this is one of the functions, and this is the startup display function. I will explain this further down. This is the main function, and we are calling the clock initialization first, and we are setting the clock to port C, and we are enabling the clock to port A and port D, and this is the printf function for the initialization, and this is for the ADC initialization, and we are calling the startup display function again. And then in this light loop we are getting the ADC conversion, and we are storing here, and we are outputting as a printf function, so it will be output here. And then when we go to the initialization of the ADC, we go to the delay function. This is the delay function, and in this setting LED function only we set the LEDs. You can see, for an example, in the multiplexing, if we want to light up this D1, this port should be high, and this should be low, and this should be tri-state. So that's what happening here. You can see here the port A is high and port C is low, and this is tri-state. So this is for the LED 1. So similarly it follows for the other LEDs from D to D6. So this is what happening in this function, set LED function. And then if we go to the next function, this is the initialization of the multiplexing. We are giving certain light intensity level values. So if it is in more than that value, the LED 1 will light up. So similarly, when it goes down, the LEDs 2, 3, 4, 5, 6 will be light up. And this is the function of initialization multiplexing. And then the startup display function is there. This function is there for us to see when we run the program initially, all the LEDs will light up, to check whether all the LEDs will working or not. And next my groupmate will explain about the demonstration.
So now I will be explaining and demoing the circuit. As you can see, when the light level is, if it has the highest intensity level, D1 will be light out, and as the light level decreases, other LED will light out accordingly from D1, D2, D3, D4, D5 to D6.
You see that when the light is near, the value of the photo light sensor is dropping. So according to the value set in the C program, each LED lights up. Here it doesn't light up properly because there's a light noise from surrounding, so you can't get an accurate value of light.